Okay, so looking at doing the T-slot joints for our control system box, they are done with a feature script just like we did the laser joints, but the only weird thing is the face that we have to touch is the one that's actually hidden behind the base part. So we almost always have to have a part hidden when we go to select them. We can do them all pretty much at the same time as long as they're not, as long as they're like the edge of the part. So like as long as there's nothing else past where this hole would go, um, in whatever direction the actual just the circle hole for the bolt would be. I think all of these ones are okay. They're all from the outside. Like we're not putting a bolt in from the inside anywhere. If you do that, you basically need to do those as a separate feature script because you have to tell it like kind of where in the part it ends. Otherwise, it tries to put a bolt like all the way through. So if we had some part in here that we were trying to put a bolt in like into this side of this plate, it would also try to put the hole over here, and we don't want that. Yeah, we don't want that. So this one is okay. All the bolts go in from the outside. So in theory, we could do every one of them all the same if they're all going to be the same length bolt and the same type of bolt. So yeah, so we can come over to our feature script button. I can click the right button, scroll down to T-slot joint. You should only have one. I have a second one because I was messing with stuff. And then we can hide whichever part we want. So I can start by hiding. It's easier to do over here actually. So we can hide like the. Okay, well I hid the right part. Um, and we're just going to click on the actual like the indent faces between the little fingers because that's where we want to have those nut slots. We can set up our settings to make sure we have the right bolts that we want. So number 10, hex is fine, machine screw, free fit, all of that is fine. Our screw length, I think it's easier if it's 5/8. I think that's the one we have the most of right now. And then since we're only doing one connector and equal spacing, it's just going to put them in the center of all of these. So then we can just click on any of these kind of open spots, and you can see it automatically starts making the T-slots for us in the correct parts, and in the hidden part that we can't see, it's also making the hole. So if we turn on, if we show that again, we see the hole there. So we can go through and do basically all of these if we wanted to in this same part. So we can go on the bottom and again through each of the different where the fingers are. If you click too fast, it will take a little bit to load, so you may have to wait a second. And then we can do the same thing with the other side. And that one, and that one, and that one. It looks like I missed one. That one. All right, so if that all looks correct, and we see that we have bolts everywhere we think there are supposed to be bolts, which I think we do, then we can just hit the check mark and it should, yeah, it should be happy and everything's running right, which is excellent. Stop showing the origin. Yeah, so there's some places where we could like choose if we wanted to. So like we could have probably done one in here if we wanted to, but it's probably not necessary. So I didn't. Like we can be with something like this where it's not gonna. This is never gonna take like impact or anything. It doesn't have to be super strong. We just want to have enough bolts that it's not gonna fall apart. Like it's very possible we could redesign this if we didn't want two on each of these sides. We could switch the number of fingers and only have like two fingers and then a single bolt on each side. So a lot of it is kind of up to you and just design intuition at some point of like, will that hold? Or if there's some other reason if it's gonna like if the nut or bolt's gonna contact something or be in the way, it may be reasonable to choose a different number of fingers and therefore a different number of bolts. You can have fingers without bolts sometimes. If you have like if we'd had like 4 back here, maybe you only do 2 bolts and you still leave the middle one empty even if you have 4 fingers. So it doesn't have to follow that pattern. Um, it's kind of up to you as the designer to kind of choose what makes sense. Um, and then also eventually we'll get through testing and we'll figure that stuff out too, right? When we build one, we can see, okay, does this actually work? What modifications do we need to make? And then luckily it's pretty easy to go through and edit some of the features like the laser joints and stuff and change those settings, which makes it very convenient for iterating quickly on a project like this. Okay, so we're gonna make this part now, and one of the ways to see that is to do section view, and we can section views over here on the far right. This little cube. We can come down to the very bottom. It says section view, and when we have that plane selected already, it'll cut at that plane for us. We can hit check, and now we basically can see right into the middle of the part. That wasn't quite what I wanted. Okay. Nor that. Are you in the assembly? This is for looking at the original file. Yeah, so looking at the original file and you're in an assembly, you can go ahead and do section view. Do it that way. Okay. So yeah, it should be if you're in the csbox.zip, the original like imported one, you should be able to do it. I don't know why you wouldn't. Okay, so if we isolate this part, we can right click on it and do isolate. Now we have a nice view of just the part that we're going to get the dimensions from for our remodeled version. So a lot of what we're doing is just figuring out some of these dimensions. So we have like a length, it's 8 1/4 all the way across. They are, wrong button. They are 3.3 to the top, which is a little bit odd. So we'll probably adjust that length to something more reasonable than 3.3 inches. I don't know what that was based off of in SolidWorks. I imagine it could easily be 3.25 or something and keep everything on our kind of fraction standards. So that's the first rectangle we would draw, right? So we have this 8 1/4 by 3 1/4 coming up, and we can see that like these points meet basically, so we can draw from that corner going down to get our dimensions in the right spot. Let me get back in the part studio. And we can draw our rectangle, our normal corner rectangle. It's a little bit weirder if let me see, if I hide this left side, it should make it easier. There we go. And I can draw it out, and then we can, I'll put it back down in the right spot in just a second. So this is 8.25, and then we said this could be 3.25, and we're probably fine. And then we still have blue lines because this didn't have a corner anywhere. So if I drag it, oh, nope, it doesn't quite like that. So I'm going to click the corner, then I'm going to click that because these are off axis. It doesn't let you drag it as nicely. But if I click them both and use either the I shortcut or come up here to coincident, it should let me put it back down on that line where I want it. So this is the right size, right? We have like this plate is lining up with this back plate. Everything's kind of in the right spot for what we were doing. Then we have to start looking at these other shapes. So this part's a little bit different, right? Because we have these like uniquely drawn fingers that aren't something that the laser joint feature script can do for us, not as easily. So this one it could do if we wanted to. We could make it do this singular one if we drew it differently. Like we could draw this, we could draw a box in here, tell it to use the feature script, and we could make that. But since we know the size of it and it's just a single one, it's probably easier to draw these both into our sketch and then remove them from this plate using a new feature that I don't think we've used yet in any of our trainings called Boolean. I think we may have used it once, but I don't know if all of you all were here for it. So we're going to draw part of that. We'll get the dimensions from in just a second, but we're just going to drop the rectangle for us. And this can be anything. We know these have to be coincident, so we'll use that I keyboard shortcut again. And we'll do the same thing down here. We have this like straight line, line, angle, line shape that we'll mimic over here too. So we just grab this, grab our line tool, and sort of do the same thing. All right, you don't have to connect it because OnShape figures it out anyway. So we're just gonna get a few dimensions. 0.495, we're gonna call that half inch. 0.4, that's probably fine. 0.469, and whatever that one ends up being. So yeah, so we'll do this as a quarter, we'll do this one as half, and we'll do this one as 0.4, and that'll define this slope as well, or it should. So we'll use our D tool to get to dimensions, except I clicked something weird, so let me do that again. There we go. 0.25, 0.5, and 0.4. Okay. Oh, we didn't get our full width. That's the one I need. So I need the distance between this one and this one, which is 0.8. So the reason I knew I needed that was these were still blue, so they should have been fully defined, and they weren't. So because they were still blue, I knew I had another dimension I needed to find, which was this one, and I can draw that to 0.8 inches. And then it's still blue because I haven't told it how far away from the edge it is. And so for that, except let me isolate again. I got out of that with escape on accident. Okay, let me isolate that and come back to here. And we're ½ inch from this back side of the board. So still using dimension, I can click in there and I can make this 0.5. Yep, that lines up to where this is on that line. So that's looking pretty close to what we want. Everything is black on this now, so it is fully defined. I don't have to do anything with this angle. The way the heights and everything else worked out, that forced this angle to be exactly where it was. We can look at these two holes. If we want to do these in Sketch, we can. So we can figure out what dimensions we did here. These are cut at 0.18. These are just for a zip tie, I believe, was the plan in the original design. This may change before we actually make it, but we could CAD these now if we wanted to. So they're 0.18. They are, that's min distance. Let's get center distance 0.3 away from this edge is how they're drawn. So we could do that if we wanted to. We could use the circle, so just C for that. And then we can draw it out as 0.18. Maybe, there it goes. And then we have the same thing up above it. I'm going to not dimension that. I'm actually just going to make these two be equal. I'm going to click these two dots and make them be vertical. So now they're on top of each other. And the only thing we didn't know was how far this was from like the plate or something like that. That gets a little trickier because I have it all isolated. See if I don't isolate it, I should be able to do that. And now our center distance, well, that's a confusing number. Why did it give me negative? Okay. Let me grab it from like that edge. Oh no, it's still negative. That makes sense. So yeah, so it's negative 0.0122. So it's actually just yeah, so that 0.122 is the number that it was sketched on. We could go through and pull up the SolidWorks if we wanted to figure out exactly what dimensions he was doing. I don't, when we originally CAD'd this, I'm unsure what that ended up being. But for now, we can do this. So this 0.122 inches. And then we can set, wonder if this gets set to something reasonable. Yeah, that's probably what happened. It's probably 0.5. Okay. And so now we have those holes. They're still blue because they're not fully defined, so they were missing a dimension from like the side of this, right? So we can figure out what that is, which is 0.3, which I think we looked up earlier. I just forgot to do. Oh, and it was already drawn pretty close to that. Okay, so these things like this definitely, because we're kind of copying it, they get a lot of dimensions in here, so it's a little bit trickier. But we are just going back and forth and pulling the dimension to make this right now, so that's fine. And a lot of times our sketches will get this complicated as we're kind of laying out different parts. We can choose to do things in multiple sketches if we want, so we didn't have to do this all in the same sketch for this part. We could do one, we could extrude this part, and then we could come back in and put the holes in second. Like we could either do a hole feature if they were going to be bolt holes, or we could draw them and do extrude remove. Either way would work. Coming over here on this other edge, we still have a undimensioned box on this side. So we can come over and figure out what's happening here. These ones are a little different. They're going through holes that are in this plate that we're going to add. So these only have holes up at the top here, and then we have the size of this this one finger on this side. So it's a 1/4 inch deep. It is a 1/4 inch from the edge of the plate, and my guess is a 1/2 inch wide, which it is. Okay, so that's easy enough to do. Same dimension tool over again, 1/2 inch wide, 1/4 inch from here, and that should be in that right spot. And then we just have those circles to do the holes that we're going to put in. These ones are slightly smaller for some reason, so they're not even the same size as the other hole direction. I'm not entirely sure why. That may be something we want to go in and correct where they're all the same size. But it doesn't really matter if a zip tie is just going through this. It could be a circle, it could be a square if since we're lasering it, it could be like any shape we want. But 0.17 is fine, and then we know that it is 0.125 center distance, and I'm guessing it's 0.125 to the other center as well. It should be, yep. So this is just drawn on a 0.125 from this edge and 0.125 from that. So it's an 1/8 inch up and an 1/8 inch over is the center of those holes, which should be relatively easy to do. 0.17, and then we just have to use that dimension tool again to keep making sure everything gets fully defined in our sketch. Maybe if I could type. Okay. And then we have another one. We could do a whole host of ways to get this too. One of the easiest ways is probably to switch to the line tool, and Q makes us have construction geometry. I'm just going to draw a line up through the center of this, and I'm going to very quickly make a mirror of this circle over on that other side. That way I didn't have to figure out where, like how far apart these were. I didn't have to figure out any dimensioning anywhere. We know exactly where that is. It's mirrored across the center line of this finger, which is what we wanted. Okay, so nothing in my sketch is blue, so everything's black, which is one of the more important things, so we know it's all fully defined. We're super happy with that. There is one critical thing I did not draw yet, which we should draw before we extrude this, which is this huge opening in the middle of the part, right? I just drew a big rectangle. I didn't account for this cutout. So I can do that pretty quickly. It's just another rectangle. We just have to know the dimensions. So it's 155 up and 575 across. So again, we can just do rectangle, which I believe is G for corner rectangle. I selected it, grabbed it from here. Come over, and I already forgot the numbers. 575 So 575, and one more time. It's like something slightly weird. 155. Okay. 155. All right. So again, this is blue just because it doesn't have a dimension out to the side yet. So we have to tell it one last bit, which is how wide this is. And it is 1 inch. So that's easy enough with the dimension tool. Nope, that's the rectangle tool. Dimension tool. 1 inch. So again, everything is basically black. The only thing that's not is the end point of this line. That's not super important. This line doesn't matter as long as it exists. We could draw it to anything. We could set a dimension on it if we wanted. We could throw it right there. It doesn't really affect anything as long as it's a construction line anyway. Okay, so since everything is kind of defined in our sketch now, that we believe we need, at least for the beginning, there's some other holes and things that we're not going to do in this sketch. We'll do a little bit later. We can use extrude to make this part. We do not want it to be an inch thick. We want it to be the same thickness as all of our other parts. We're going to use that thickness variable. And when we click off, it should preview properly. And we have the correct part. We're on new because we know this is a new part. There's one part that our preview is kind of messed up. It's leaving this cutout bit that we don't want. So we're going to actually click out of that. And now we have the rest of these parts. So we have the holes that we want. We have the rest of this part showing. Everything else in there is the part we actually want to extrude. We just don't want that middle bit. When we hit check, we should get the part, and we see that we have some overlapping. So we haven't actually, like, these two parts are occupying the same space right now, which is what we're going to deal with next. All right, so now that we have this shape, we're going to make it so that these two parts don't overlap, and we're basically going to use this part to tell OnShape what material in here to subtract. We're going to do that using the Boolean feature. So Boolean is a type of logic, like and or not. We use it in computer science and things, but we also use it here for how we want to subtract or union parts and things like that. So union lets us add things together, so we can take or we can combine two parts together with union. Subtract is the one we're going to use. Intersect lets us take only the, or lets us keep only the bits that touch each other. So if you had these two on intersect, it only keeps the parts that overlap. Definitely not what we want. Union, like I said, it keeps everything. So this all becomes one part. But what we want to use, the one I use the most, is subtract. So we're going to tell it the tool is this. So this is the part we want to keep. We're also going to make sure it keeps the tool because we want that part to still exist. If we didn't have keep tool, it would just delete this because it thinks you only drew it as a thing to remove. So we're going to do keep tool. And then our target is the part that's actually going to get the bit of material removed. So we're going to click right on this, and it's going to remove it. So you can't tell much, but you can just tell that it's no longer doing that kind of bluish whatever overlap, or just a little bit. If we move it all the way to final, it won't do it at all. I don't know if we really talked about this slider at all. So this slider lets you see whether, like, how much of the preview you see. So that all the way back to here, there's no preview. And so this is just like it looked before. As I move it forward, it starts making the bit that's removed starts becoming more and more transparent. If we see it more in union real fast, so like if I have it on union, this is full preview. If I bring it back, it becomes more of the blue. So we can kind of see what that would look like. Okay, so back on subtract, the actual part we're using. Tool, target, keep tools is good. You can offset, so if there was some reason we wanted to have slightly more cutaway than we needed. This may be a little awkward here because I think it's going to offset in places we don't necessarily want. Oh, maybe not. No, so you can like select specific faces to offset and things. So you could go in and tell it to like make these things wider if we want it to not be an exact fit, we could offset if we needed to. So you can offset all, but that got a little weird, right? Because it started offsetting this top face, which we don't want it to do. But you can see it doing the correct thing here. If you didn't do offset all, if you just selected faces, we could hide this. We could go in and figure out the faces we wanted it to offset around if we needed to. For now, we won't worry about offset. The laser should give us enough tolerance to push these parts together, even if they're supposed to be like exactly the same size. Okay, we're gonna go ahead and hit check. And now we can, if we like hide this, we can see that this now has the holes in it that we wanted. Okay, so I paused recording and I forgot to come back. So we did a couple things. We made this plate and we did the mirror for this other part. We ended up moving the mirror up above the Boolean and just editing the Boolean to have two tools. So it has both of those. I'm going to edit, I'm going to rename this to be right Rio plate. So we have the name in here. Okay. So there's definitely some stuff we still need to add to some of these as we get more features. We'll look at as we input parts, but I think we're pretty close. Now that everything's in the right place, at least, we can make the assembly. So I'm going to make a new assembly for all of this. The one we currently have is just kind of a test bed assembly. We're going to insert this entire part studio. Just go ahead and hit check. And then I'm going to make all of these parts be in a group. And I'm going to do the bottom side. I'm going to go ahead and fix it. So now the entire part studio has been put into the assembly. I can't drag or move anything since they're all grouped and a single part is fixed. We could start putting in some of our actual components from MKCAD if we wanted to. So we could start putting in the battery, the RoboRio, all of those types of things. But one of the things I wanted to show is how the standard content library works, which is very convenient. So we can go to insert, we can do standard content, and we can put nuts and bolts and things like that in a lot easier than having to insert them from MKCAD every time. So if we wanted to have a button head 1024 and we wanted it to be, say, 5/8 long, we could do that pretty easily. I can click insert and let's see if it'll let me do a thing. It basically lets me put it in with a make connector. So I can just, it automatically like grabs onto that hole. It'll let me move around which way it goes sometimes if I do it right. What did I do? There it goes. So now I have that bolt. And you can basically do that over and over again. And that's basically in the right spot. We can see how long it is. It's the correct length for this. So we have our bolt ready to go. If I haven't seen yet how to do, let me double check how we do nuts. We can do it in the same way. We can flip over to nut. 1024 steel plane. That's fine. And then if we insert, this one may get a little bit weirder. We may have to offset to a certain distance with these to make them the way we want. There may be some other way I haven't thought of yet to do that. Oh yeah, it'll let you actually put washers and things underneath, which would be convenient, or a nut or anything. So if there's times where we need to put in even more hardware. There's probably a faster way to get these into the nut pockets the way we want them. One of the ways is by doing, oh, did it not go where I clicked? Did I click somewhere else? Oop, I clicked off it for some reason. So one of the ways to do it is by going and putting it in kind of a normal spot and then offsetting it. But I don't know exactly how that would work. Let me see what that would look like. So that one ended up being fastened to two different, oh no, it added a make connector. So if I edit, okay, that's interesting. So it put them in between. So that's not actually what I want because we don't want to do that. We want to eventually have it to where that nut is offset from the front of that hole. Let's see. So if we do it on one that's blank, we should be able to do that a little bit easier. That may be one that we have to do ourselves. But we can see we'd be moving it back on the z-axis some amount. I don't know exactly. Oop, it's probably negative. Yeah, so that went a little too far. So that went the full 5/8. So that made it to the exact back edge. This dimension is set up in our T-slot joint, so we can know what that is. I'd have to figure out what that is. We can probably go get it from the Part Studio. From our T-slot joint feature script. Maybe not. It's somewhere. I think it might be defined actually inside the feature script itself, but it's easy enough to know what that is just from clicking on one of these. We can measure. It's 0.061. So if I can edit this, we could go in and we could add back that 0.061 if we wanted. And that'll put the nut in the correct spot. It's not rotated exactly correct, which is annoying, so that needs to be... Oh, that's rotated thing the wrong way. Interesting. Rotate about Z. Thank you. Nope. 60, right? Nope. 30. I was right before. Okay. Yeah, so that actually puts the nut where you can kind of see how this would go in. The flats of the nut go up against the flats of the material. It's the right distance away. This is probably not the most ideal way to do this. There's probably a better version of this that I need to probably work out and figure out a better way to set this up to where we can put them all in. For the bolts, it's easy enough to replicate them, which is a replicate. We can choose the feature. We can choose faces defined match. So if I click through the rest of, if I just click on this face, it automatically chooses that there should be a bolt in those 3 holes. I can do the same thing for like the bottom. It chooses that there should be a bolt in all of those holes. Like it knows where all the bolts basically should be based on the size of the hole that already existed, which is very convenient. What am I looking for? K. K is hide, show, make connectors on the keyboard, which is convenient, so we're not seeing all of them for the bolts. One of the things I haven't figured out a fix for in a way that I like to do is all of the bolts show up as a part, and currently you can't make folders in OnShape assemblies like you can in OnShape Part Studios. So in here, if we wanted to make specific, if we wanted to make the features for a specific part inside of a folder, we can just do add selection of folders. We can name this folder like bottom plate. And now the 2 features that make up the bottom plate to begin with are there. We can do the same thing later on for other features. And you can keep your feature tree really organized inside the Part Studio. Inside the assembly, you can't do that as easily, and that's less fun. So there are some things you can do. You can go in and you can like, we can move all of these to their own subassembly. We can move to new subassembly, which partially works. It's just a little awkward to do that because now you have a whole nother subassembly that's just a bunch of bolts, and makes it a little bit trickier to edit and move things around if you need to. So it's not ideal, but it does work. So there's something like that that could work as we go through and if we need to actually have all of our bolts in place.